This is my Celebrate the Mouse video essay on diabetes. When I was little, my grandma was diagnosed with type 2 diabetes. I remember anytime she would visit, she would poke her finger and draw blood to check her blood sugar levels every day. At that time, I absolutely hated shots and needles, so I thought it was a horrible way to live. This inspired me to do research on diabetes because I couldn't imagine having to give myself a shot every day, and I want to know if there is a cure. So what is diabetes, you may ask? Diabetes is a chronic disease characterized by the body not being able to properly produce insulin, leading to hyperglycemia. Well, what is insulin? Insulin, as seen in the infographic, is a hormone that regulates one's blood sugar levels. There are two main types of diabetes, type 1 and type 2. Type 1 is most noticeable in the early years of someone's life and is due to an autoimmune destruction of insulin-producing beta cells in the pancreas. Type 2 most commonly develops later in life due to a high-fat diet and insulin resistance. So why have researchers decided to use mice in the study of this disease? Well, for starters, mice are relatively inexpensive. They also have short lifespans and reproduce quickly, allowing researchers to see the generational effects of diabetes treatments. Mice share the same cells, organs, and tissues as humans, making them the best surrogates for humans in the lab, and they also have similar endocrine systems to humans, allowing them to develop both type 1 and type 2 diabetes. With there being two different types of diabetes, there are also two different types of mice used in the research of both. In type 1 diabetes, researchers use the non-obese diabetic mouse as it develops type 1 diabetes spontaneously, like humans would, and gives researchers insight into the genetic and immunological causes of type 1 diabetes. In type 2 diabetes, researchers use the diet-induced obesity mouse as it mimics the common cause of type 2 diabetes in humans, high-fat diets. That's why it's great going to my grandma's house, as she doesn't eat all the sugary foods and I can have them all for myself. The scientific mice used for type 1 diabetes are the LEPOB and the LEPRDB, and this type 2 is KK-AY. There are many different ways that mice have been used in the research of diabetes, but I want to specifically focus on gene therapy in mice as was the most interesting to me. On April 21, 2003, Lawrence Chan, who is a researcher at Baylor College of Medicine, Houston, Texas, and his colleagues made a shocking discovery about gene therapy in mice. They started their research off by using an antivirus vector to induce two genes into the mice to produce diabetes. Side note, these mice were already treated with STZ or streptozotocin. They induced neuron, which is required for the development of pancreatic islets, and BTC, which is a hormone that stimulates the growth of B cells, which are the islet cells that secrete insulin. This type of treatment led to the total reversal of the diabetic condition in the mice. Through this research, the mice are able to develop isolate clusters in their livers, allowing them to produce insulin. After 3 weeks, the STZ mice treated with the neuron BTC had normal blood serum levels, and 3 months later, the mice still showed normal glucose and insulin levels. Chan reported that he hoped to later repeat this procedure in larger animals and eventually humans with diabetes. Chan also plans to research a safer vector to deliver the genes. He believes this gene therapy is better than others as it coaxes the body to produce its own insulin. To conclude, diabetes is a big issue across the globe as 537 million adults currently are diagnosed with it, and that number is only projected to rise. Hopefully, through the use of many mice in different research experiments and lowered food prices on healthier foods, the world can help to combat the rising numbers of diabetics. So thank you to the mice that are leading the way to a healthier and happier community.